Hello there. Hello, Peter. We have a special guest today. As we promised the last time, hello, Frederica. So we have
Hello.
Peter, policy agent there. So thank you for being with us. Today, we wanted to talk a little bit and learn a little bit more about the Open Policy Agent. As last time we talked in general about policies and also in particular about challenges in that respect. And we also said that there are solutions out there, which one is open policy agents that can help address those challenges. I'm going through those challenges just very quick, and then I will give the stage to Peter so that he can teach us and give us from his know-how and knowledge on how can we actually address those challenges with open policy agent. And those challenges are, for example, aligning policies with business goals, avoiding contradiction and or overlapping policies, enabling consistency, decoupling policies from application logic, and decoupling policy decision-making and enforcement. And there are many more, but these are, let's say, the main ones that we have identified and addressed last time. So Peter, thank you again for being here. It's our pleasure to have you here. So please, the stage is yours.
Cool, awesome. Hey, it's great to be here. Thanks for having me on. And yeah, so I'm Peter. I'm the community advocate for the Open Policy Agent project. And so I get to work very closely with a lot of our community members, but also very closely with our maintainers who are working on the project and contributing code. And so I think I'll kind of dive into a little bit about how OPA works, which aligns very closely with some of these goals that you have stated here, right? And so OPA itself is a policy engine, right? And so it's a standalone policy engine that runs separate from the rest of your application or your services or whatever the thing is that needs a decision, right? And so this decoupled policy engine, how it works is it stands on its own, and when a service like, let's say, Kubernetes or your cloud provider needs to understand how something is going to respond to a policy, like let's say if someone needs access to a service or if a service needs access to another service, right? The policy engine is going to sit and run. And when that occurrence comes up, it will reach out to the policy engine and say, hey, here is a set of data, set of parameters that I've collected from this event. Compare this to the policies that you have and send me a response with how to respond, right? And so this behavior is known as like decoupled policy decision, right? So it's decoupled because that policy engine is not sitting within the application, which is I think the fourth topic you have here, right? And so being able to decouple that process gives a number of benefits, and so that is baked into the OPA infrastructure. And so with that, right, OPA is designed to be decoupled. And so a big part of how that works is that it is designed to be a general purpose policy engine, meaning it works for anything that you want to use it with. And so being able to work with services like microservices or applications or cloud providers, any of those things, what it needs to do is it needs to be able to communicate with all of them. And to communicate with all of them, it has to have a kind of common language. And so what that is going to be for OPA is it's going to be what is Rego, our universal policy language, which essentially takes a novel approach at creating a policy language creating a programming language specifically for policies, right? And so instead of reusing like Go or JavaScript or something else out there, right, we've created this declarative language, which allows us to take in data, pass that to OPA, the policy decision, figure out what needs to happen, right? Because the policy language understands date and time, cryptography, just about anything that we have 150 different built-ins that are currently in it right now, and that's expanding all the time from the maintainers and the community. And so with that, we have this two-prong approach, which is, while there are other decoupled policy products out there, right? Not many that I know of have their own dedicated policy language like OPA, and the policy language itself is called Rego. So we have this two-part system that works hand in hand that creates this policy dynamic, which works across the board, right? And so, as I said, so it is actively maintained, and new things are popping up all the time. One of the primary maintainers and also the founders are Styra, the company that I work for. And so you'll see new features basically pop up almost monthly. That's about the cadence that new releases come out. So you'll see either new built-ins or new functions that come out to handle different types of policies. So OPA is ever evolving in that sense. And so is like the land of policy, right? Like we're always discovering new things that we need to add to compliance and new things that we need to be ready for. And so having a policy engine that's also updating for the current times is a really good thing. And so with Styra, right, not only are they the founders and one of the primary maintainers, they also offer enterprise solution called DAS, which essentially is a central management platform, which helps with that aligning with the business goals, right? When you're deploying OPA and you're deploying OPA at scale more precisely, right? You might have hundreds, if not thousands of services that are going to need policy decisions, right? And so you might be interconnecting multi-cloud, and this process requires not just one OPA running centrally, right? You don't want to have that single point of failure. You want to have that policy decision spread out across your entire application and infrastructure, right? And so with that, you get a couple different benefits. One, as those OPAs become closer to the services and the applications, you're lowering latency. But then two, you also have this sort of distributed model, which makes everything perform much more in a much more optimized fashion, right? But having a distributed model like that requires having that central place to kind of control everything. And that's where Styra offers the Styra DAS platform, which essentially acts as your authoring tool to write the Rego policy language, but also as a management centralized location to store your policies and to also kind of understand the health status of all the OPAs running out there. Because at some point, once you're deploying everything, if you don't have a centralized managed service, you're going to end up building one yourself anyway, because if you have 1,000 OPAs, you don't know which ones are operating and which ones are updated and which ones have the latest bundles, right? You end up building something to figure out this information anyway. So Styra DAS is just a pre-built system that works for that. And so with that's kind of like a high-level overview of how OPA works with the decoupled policy model, and then where the maintainers and Styra falls in. And then like what's interesting there is OPA is coming at a very particular time in a kind of the evolution of the cloud stack, because if you look, like with OPA and Rego, right, we have this declarative policy language, right? And declarative is such a powerful tool that has become very popular in the last few years, where we want to be able to say, my application should run like this. My infrastructure should look like this, right? And once you declare what these things look like, you kind of want your system to figure out how that looks and to just make it happen, right? And so with OPA and Rego, now we have this kind of declarative approach to compliance, right? We have this declarative approach to policy, right? We are adding on to what has kind of become a default standard in the cloud stack, where you want everything to be predefined and understandable based on what exists in your Git repository, right? You want to be able to check your application into Git. You want to be able to check your infrastructure into Git. Everything should be versioned and controlled and understandable and readable based on something that is saved. And right, so that declarative model is something that has become very powerful and very accepted over the last few years. And so OPA is adding to that modern cloud stack in a language that is preferable for a lot of engineers. And so with that kind of gives this high level overview of these points. And so looking back on the Fiberso topics that you talked about, we talked about a couple of them here, like decoupling policies from the application logic, which is built into how OPA is designed. We have the like aligning policies with business goals, which is kind of like having that centralized business or a centralized tool like Styra DAS, right? Being able to say like, oh, all our policies live here, right? And you can define out your business goals and easily compare what is going out to what exists into your policy library, right? That kind of, those things kind of happen there, right? And then with these written policies here, right? The second one you have listed is avoiding contradicting or overlapping policies, right? With a centralized policy location, you can also reuse policies. So being able to have your policies in that central location and having a universal policy tool means that if you have a policy, let's say something very simple, for example, like all admins have access to all prod services, right? Now, all of a sudden, that policy that sits there can be reused, right? So you don't have to write a admin access policy across all of your services, right? You have one policy, and since your policy language is understood across all your services, that just gets pushed out. You don't have an overlapping or contradictory policy, right? You just have one policy that's understood, right? And then enabling consistency here. Like once again, when you are centralizing management and control, right? You're able to see which ones, like especially in the OPA ecosystem, right? You're able to see which OPAs have pulled down your policies or your bundles, as we call them, right? And at what time. And so understanding that all of them have the latest bundle, or if something is running behind, you understand that those services are at risk of not following the latest thing, right? But you need that sort of centralized kind of point to funnel that information through. Otherwise, you run the risk of having to check multiple places to see that everything is consistent. And then I think that covers each of the points that you have here.
Exactly.
Yeah.
It sounds like with Styra DAS, with this the commercial product, you do address all these challenges that we have just listed last time, and you addressed this already here. It means that gives you that transparency and overview and control and management, as you put it. With respect to all the open policy agents that run in your infrastructure and the bundles they do use for making and enforcing policy decisions. Maybe I have one question for my understanding with respect to this. The Rego is the policy language, the declarative policy language that OPA is using for making a decision and for enforcing that decision, right? So my question is here for me to understand how actually is this language, or are all these microservices and other systems interfacing to that policy language? So how you still do this interfacing between the different applications? So you are decoupling the logic from the application and putting into this declarative mode, but how are you, let's say, extracting those parameters from a specific microservice and application, transforming them to the Rego language, giving them to OPA to make the decision or to give you the, let's say, the response back, should you allow or not allow?
Cool, yeah, great question. And so we use something very simple here, right? It's called JSON, and right, this is something that has been around for quite a while, and pretty much every service understands how to package something as a JSON object, right? And so the OPA service, as it's running and waiting to run a policy, is sitting there waiting for a bundle, which it will have received a bundle which states which policies can run. So it'll have its policies, and then the second bit will be a data package, which will come from your service or application, right? And so those two things together will allow OPA to make the decision, right? And so that data package can be just about anything that can be packaged as JSON, right? And so that can be user information, that could be cryptographic information or a hash of a password, right? And so what's interesting there is like the whatever you're sending to OPA then can be modified, and what you're shipping back doesn't have to just be a binary yes, no, you can do or you can't do, right? You can actually send back modified data that can say, oh, you based on this user, you can access between these times, right? So I'm going to give you a token that lasts for X amount of time, right? And so you can modify the data that comes in based on your Rego policy to ship something back. And so you have a lot of flexibility there, not just a policy yes, no binary.
Okay, I understand. So it means that all the services need to pack their inputs in a JSON format, pass it by to OPA as the data input, and together with the bundle, it will decide or it will modify that according to policies and give an answer back, which can be simple and complex at the same time, right?
Correct. Yeah, spot on.
Perfect. Sounds great. I have no questions from my side. It was really insightful, very helpful for me as well. Frederica, do you have any question maybe from your side? Or
I just wanted to ask if you have some challenges or using policy challenges which OPA is covering or something like that we didn't think about. Do you have an idea we forgot?
Interesting. Yeah, like what's fun there is like, because OPA is like it is this universal policy language, right? We've designed it to work pretty much everywhere. What's fun is the community itself tends to come up with new things all the time, right? And so the community, we are heavily in Slack and we're heavily in GitHub discussions, right? And so people will come up with questions and say like, oh, hey, there is a new tool out, or like Kafka has these new plugins. How do we connect these things? And so yeah, like I would say that the potential there is that, right, there is like an unknown number of things that can work with, and so there's no one specific service. I would say that it's fun to figure out how OPA works with the services that you're already using, even if they are obscure and you do have something very special in your tech stack. Understanding how to connect those components to OPA and your policy definitions, and then making everything work together.
Great, thank you.
Yeah,
so
definitely.
We don't have any questions right now. Do you want to tell us something more, or
I think that's good.
Invite the community.
Yes, definitely. That's always a good one. So if people are interested in learning more about OPA, openpolicyagent.org is our website. From there, you can find our Slack channel and our GitHub, and you can use that to get in contact with us. We are very responsive as a community, and yeah, I look forward to seeing new faces.
Great.
Cool. Yeah.
So,
thank you very much for the time. Thanks for your insights, and maybe we have the chance for another discussion more in a specific case that we can shed light on maybe another time. Thank you very much. Thanks for your attention, everyone, and yeah, see you next time. Thank you. Bye.
Yeah, see you next time.